Hey guys, welcome to our video. We are rounding the bend into the final stretch of this unit. This unit has been a little bit on the long side, which is why we've broken it up with quizzes. But welcome to the last section in Unit 11, yay! Okay, so our I can statement for today is, I can compute volumes of rectangular and triangular prisms. And if you don't know what I mean by a prism, that's okay, we're going to talk about it in just a second. So we're talking about prisms today. So for a warm-up, how would you describe the difference between area and volume? Area and volume. Pause the video if you want to think about that for a second. You might know what the difference is, but putting it into words, articulating that can be a little bit challenging. Usually the best way we come up with to describe it is area is two-dimensional. And when I say two-dimensional, it has length and width, right? Kind of like this paper here. It has width here and length here, but it doesn't really have any height to it, does it? No. Whereas volume is three-dimensional. So think about like maybe a shoebox. It might be the same shape as this paper. It might have width and it might have length, but then it would also have height. It'd be raised up off the ground. So that's the difference between area and volume. So we're going to be talking about volume today, three-dimensional shapes. Let's keep going. It says, let's see how we make volume from area. That's right. How we make volume from area. We're going to be computing the area of parts of the shapes and then using that to find the volume. Let's keep going. We'll start by drawing a parallelogram and a triangle and build from there. Okay, so what we're going to do here is we're going to draw a prism with a rectangular base. Now you art people out there, you probably already know how to do this. And I'm going to do my best. I'm not an art person, so just stick with me. So this is going to be rectangular base. So even though it's a rectangle, I'm going to draw my base looking a little bit more like a parallelogram, and you'll see it come together in a second. So this is the bottom of my rectangular prism. Again, for a rectangular prism, think of something kind of like a shoebox shape. So that's the bottom of my shoebox, and now let me do the height of the shoebox. So we're just kind of doing all the little upwards corners, edges, I should say. All right, those are all the edges going up. Now let's put a top on the shoebox. So draw it over, connecting all of those, and then you have your shoebox. And this is not perfect, but it's okay. Maybe yours looks better than mine, which would be awesome. And then if you want to kind of erase the background ones, you could even make them dotted if you want to. That's what we're gonna do. Like, let me slide this around. See how these are dotted? Can you tell on this video those are dotted? Like the ones that are in the background of the shape are usually going to be dashed or dotted. So that's just what I'm going to show right here. So the solid lines are like the lines, the parts of the shape that are close to you, and then the dashed ones are the ones that are in the background. All right, so there's our rectangular base, our prism with a rectangular base. Now let's do a prism with a triangular base. Okay, so let's draw a triangle. So this is the base of our triangular prism. Now a triangular prism is different from a pyramid, so make sure you're not thinking pyramid here. Let me show you what this is going to look like. Just like in the rectangular prism, we're going to draw lines going straight up. So there, there, and there. And then I have to connect those for the top of the triangular prism. So connect, connect, and connect. Okay, so now just to make sure, because like to some people that might look like a tent and some people it might pop out the other way, let's just make sure those lines go to the background and the ones that we want come to the foreground. So just kind of dash everything like that. And then you can kind of tell that this side is coming towards you and the dashed ones are further away from you. Okay, so that's what a triangular prism looks like. It's basically a triangle on bottom and then still stacking triangles all the way up. So what does it say here? It says we figure out how many squares fit on the bottom. Okay, so when we're talking about how many squares fit on the bottom, like look at this rectangular prism, you would just want to figure out how many squares fit in there. This is another way to say something that you're very familiar with. In other words, we are finding the area of this shape right here. The area, the two-dimensional area of the bottom. Once we know how many squares fit on there, we're going to see how high we can stack them, and then that's going to tell us the volume. So we figure out how many squares fit on the bottom, and then see how high we can stack the cubes. So When we're thinking volume, instead of thinking squares fitting inside a flat shape, think about cubes fitting inside a three-dimensional shape. So I don't know how to draw cubes like on this scale, but pretend those are all cubes. Oh, that kind of looks good. Seriously, I'm not an artist. So I need one of you art people to come help me out. If we were in class, I'd be like, volunteers? And I'm sure you guys would come up with something awesome. But you're not here to help me right now, so you're just gonna have to make do with what I've got. Pretend those are all cubes on the bottom, and your job is to figure out how many cubes fit in this shoebox. That's what you're doing when you're finding volume. Okay, so what we're gonna write here is cubes. We're seeing how high we can stack the cubes. You could do something similar over here. You would see how many squares fit, and then you're gonna see how high they can stack it. Now you're not gonna be doing this by drawing a bunch of lines like I just did. You are going to be doing it by using your formulas like length times width and things like that. Let's keep going. Now that I'm done drawing, I'm going back to my pen. So volume is the three-dimensional space that an object takes up. So it needs to have length, it needs to have width, and it needs to have height. Rectangular prisms have a rectangle for a base. Okay, so that means the bottom of the shape, the bottom of the prism is going to be a rectangle. Triangular prisms have, guess what? A triangle for the base. Okay, and then prism, I told you we'd come back to this. Prism is just a fancy name for a box. So like we talked about a shoebox here, I can't think of any boxes that are usually triangular shaped, but I'm sure they're out there for something. Let's keep going. To understand the formulas for prisms, we need a vocabulary word. In this case, base with a capital B. See that capital B there? All right, so base with a capital B means the bottom of a shape. Actually, I think what they want us to say there is area. Scribble that out, so sorry. So the base is the bottom of a shape. But when we're using capital B in a formula, what we want to do is find the area of that bottom of the shape, and that's what the B is representing. So let's put area in this blank right here. Okay, so capital B means the area of the shape that forms the base of the prism. In general, the formula for a prism is volume equals base times height. And when I say base, make sure you say that capital B. And the reason we have to do a capital B is because remember when we did like parallelograms and we talked about base times height, right? So this base is just a two-dimensional measure, whereas this base, actually this is one-dimensional, sorry. And this base has two dimensions. So this base indicates area, whereas this base only indicates length. So there's definitely a difference here. All right, so this is the easy part. For rectangular prism, you're gonna have to memorize this formula. It's volume equals base times height. And triangular prisms, still really hard. Volume equals base times height. So in both of those, you're gonna calculate the area of the base, and then you're gonna multiply by the height, and you're gonna be good to go. Let's read this box now. You know you've chosen the correct side as the base of the prism if you can slice the prism parallel to the base and get the same cross-sectional shape every time. Do you guys know what a cross-section is? Like if you take like a hot dog and you slice it, those are cross-sections of the hot dog, something like that. So if you had this rectangular prism, think about it like a shoebox, and you sliced off bits of it, then those would be cross-sections of the shape. Now think about this triangular prism. If you do slices this way, all of your little cross-sectional slices, they will all be a triangle. Can you imagine that if you just took a chainsaw right through the middle, you would get a triangle here. So that shape, if you, let's see, they're talking about slicing it parallel to the base. If you slice it parallel to the base and you get the same shape as the base, you know you've chosen the base correctly. If you get a different shape than the base, then you might have chosen the wrong base. And sometimes they turn them on their sides, so you don't know. Let's look down here for some examples. Like this one right here. So let's pretend the bottom of it is the base. I think that's right, but let's just check. Let's take our chainsaw and slice it in half. Okay, zoop. We're gonna pretend that this is cutting it. And oh, good. It looks like we wound up with a triangle, so we definitely did it the right way. Now what about this one? Let's take our chainsaw and just slice it the same way. And we're going to go from here to here, there to there, there to there, and there to there. Well, it's clear to me that this is a triangular prism, right? But the cross section we just did, is that a triangle? No, that's a rectangle. Or it's a rectangle. It's just in 3 dimensions. That's why it looks kind of parallelogram-y. But don't worry about that. We need the cross section to be a triangle because it looks like it's a triangular prism. So we need to slice it this way instead. This is really hard to draw. I probably need to practice this a little bit more. This is not how I usually demonstrate it in class, can you tell? But we're doing the best with what we've got. So when you zip it straight down with the chainsaw, you're going to get a triangle. So you know that this is actually the base, because when you get a triangle by going parallel to that base, you know that's the base. I hope that makes sense. Also, if you're looking at some kind of prism and there's a triangle for a face, you know that the triangle is the base. That's kind of like the logical, common sense way to think about it. Whereas over here, you have a pentagon, right? Well, guess what? The pentagon is going to be the base. When you have a rectangular prism, it's much less important. You can kind of look at it either way and it doesn't matter. Okay, so let's do some of these examples. So find the volume, round to the nearest hundredth. Okay, got it. So what we're going to do first for this rectangular prism here is we're going to find the area of the base, because we need to figure out what that capital B is, right? So the base, I'm just coloring it in green so that we can kind of see it. So it looks like we've got, well, we know the area of a rectangle is length times width, right? So our length is 10, area equals 10 times, and then the width is 4. 10 times 4. So the area of the base is going to be 40. So I could also say that capital B equals 40, because capital B just represents the area of the base, right? All right, now the formula we're following is base, big B base, times height. So let's plug in what we know. Big B is 40, so we're going to put 40 here. What is the height? Oh, the height up and down, it looks like that's 2. So let's just multiply that by 2. And we're going to get volume equals 80. And what's our unit? Feet. Feet. Now this is the fun part. When you have volume in 3 dimensions means you need a 3 on the units. So it's going to be 80 feet cubed. You could say 80 cubic feet if you want to. This works either way. All right, so that's your volume. Let's look at B. So here, we already talked about how the base is going to be the triangle, so this is the base right here. All right, so what are the length and width and height and all that stuff? Well, it looks like it's a right triangle. This can be kind of confusing, can't it? So I'm going to say this is the base, 4 here, and this is the height. And then over here, this 5, we don't really actually need that. But knowing that this is a right angle is really helpful. If I were to take this triangle and just kind of turn it 2-dimensionally towards us, it would look like this. There's the right angle there. You have 3 there, 4 there, and 5 there. That's a lot easier to look at and figure out like area, what to use for base and height, right? You can see that 4 is the base and 3 is the height. Well, this is the same as that. So we're going to just use our formula for area of a triangle, which is 1/2 little b base times height. Okay, let's do it. So base times height, 4 times 3, actually, sorry, 1/2 of 4 times 3. So 4 times 3 is 12. Take 1/2 of that and you're going to get 6. So we know that the area of the base is 6. So I'm going to say big B equals 6. Now this is the easier part. You're going to use this formula again because it's the same for triangular prisms and rectangular prisms. It's going to be base times height. So volume is going to equal base, which is 6, times height, which is, looks like it's 7. 6 times 7 equals 42. So 42 centimeters cubed is going to be our volume. All right, so you guys seeing how that works? I think the most confusing part of that one was just knowing where the base and where the height was on the triangle. Let's go on to part C. So here we go. We have a rectangular prism, right? So let's figure out the area of the base. I'm coloring that in. It looks like it's 11 by 9. So the area of the base is 11 times 9. That's going to be 99. So now the volume is going to be base times height. So volume will be base, which is 99, times height, which is 6. Okay, I'm going to use my calculator for that one. 99 times 6 is 594. So 594 yards cubed. All right, let's look at the next one. I've already scribbled all over this one, so hopefully we can still read it okay. As we talked about, the base of this shape is really this triangle here. You could certainly say the back triangle too, it doesn't matter, they're the same. So I'm just going to kind of color this in, and our length, our base, and our height are much easier to see here than they were there. So let's see, area of a triangle is 1/2 base times height, so area here is going to be 1/2 of the base, which is 8, times 6, which is the height. So you do the math on that, and you're going to get, let's see, 6 times 8 is 48. We'll just go ahead and use the calculator on that. 6 times 8, 48. You're going to divide it by 2 because you're taking half of it, and you're going to get 24. So the area of that triangle is 24. In other words, the capital B, the base, is 24. We're going to put that into our formula, base times height. Volume equals base, which is 24, times the height. Now, what is the height of this prism? It's not this, because that was the height of our base. Remember, it's kind of tipped on its side here. The height of the prism is going to be this dimension here, that 10. So we're going to do base times height, and it's going to look like that. And so we know the volume of this shape is going to be 240 meters cubed. Okay, let's look at this pentagon. How would you find the volume of the following prism? Well, we don't know how to find the area of a pentagon, right? This pentagonal prism, what are we going to do? Well, you know what? If you look really carefully, it says right here that the volume, not the volume, excuse me, that big B, in other words, the base, is 43 millimeters squared. So basically, the area of this shape is already found for us. So we don't even have to worry about that. And what do you think we can do with it? We know that the formula for a rectangular prism is volume equals base times height, and a triangular prism is volume equals base times height. So what would you guess the formula for a pentagonal prism is? If you guessed the same thing, volume equals base times height, then you are absolutely correct. That's what we would do. We already know the base, so I'm just going to say volume equals 43, because of that right there, times the height, which is 15. So let's see what the calculator says about that. 43 times 15, 645. 645 millimeters cubed for that volume. Okay, so that's all. Wait, almost on my notes. I almost forgot the thought question. So I want you to start thinking three-dimensionally here. See if you can picture this in your heads. What do we get if we slice a prism perpendicular to its base? Perpendicular to its base. So like if the base is down here, let me show you in this picture. If the base is down here, perpendicular would be like this. Whereas before we were always slicing parallel. Okay, so what if we went perpendicular? So here, if we went perpendicular to the base, let me use a different color. How about purple? So you could do a slice here, and here, and here, and here. So we're taking our chainsaw and we're just cutting straight down through it. And what shape did we get? We got a rectangle. Okay, that's not very remarkable. What if we did the same thing on our triangular prism? Okay, so I'm going to slice down perpendicular to the base. So it's going to go from the top straight to the bottom. It's going to also go through the back. And it connects like that. And look at that. We got a rectangle. What if we sliced through it perpendicularly here? Well, we'd get, I shouldn't have done it like that. It's really hard to see, isn't it? But if we change the angle a little bit, you can kind of see that that is also a rectangle. What if we sliced through it perpendicularly like this? That would go to that side, this would go here, that one's a bit better to see. That's also a rectangle. No matter how you slice it, perpendicular to the base, it's going to be a rectangle. Whereas, as you know with the green, when we went parallel, it was a triangle, right? Now, we already did this perpendicular slice here. Remember when I did it the wrong way on purpose and we got that rectangle instead of a triangle? Well, so it's a rectangle again, right? And let's do the pentagon also. Let's go perpendicular to the base. How about we go from here to there, and oh gosh, I don't even know. I'm not sure how to draw this. I think this is working out though. You would go from there to there, and it's drawn a little bit poorly, but you can see it's still a rectangle. So long story short, if you slice down perpendicular to the base when you're doing a prism, then you're going to get a rectangle. Interesting, right? So if you go parallel to the base, you'll get the same shape as the base, kind of like a cross section. But if you go the other way, you're always going to get a rectangle. So what do you get with a rectangular prism? Both ways you get a rectangle. Interesting. All right, so this is your assignment. It's just 10 problems. Do as many as you can. We're still thinking about 30 minutes or so, right? So let's look for anything confusing. This one's going to be fine, I think. Looking for any confusing triangles. This one doesn't look too bad. There aren't any triangles here. Oh, look at the title. There we go, Volume of Rectangular Prisms. So we'll get to the triangular prisms tomorrow. So like I said, do as much of this as you can in 30 minutes. Thank you so much for watching. If you have any questions, let me know, and I will see you next time. Bye.